Thank you so much for joining us. It looks really warm and sunny, at least from your Zoom backdrop. So hopefully that's indicative of where you are as well. But thank you so much for joining us. So we have Alan Stewart from Microsoft Corporation here on our screens, and then Dominic Roche-Grace, who's a student in computer science, up here on the stage with me. So I'd like to go ahead and start by giving you both a chance to talk a little bit about what interests you, what excites you about these technologies, and then we'll go into some questions. One of our goals here is to take a lot of questions from the audience as well. So please, members of the audience, be thinking about what you'd like to ask as well. And again, once everybody gets a chance to say a few quick remarks, I'll start us off with a question, but then I'd like to throw it out to the audience as quickly as we can. So Alan, do you want to start with a few quick thoughts?
Sure. So Alan Stewart, I'm the head of software engineering in the Office of CTO in the Strategic Missions and Technologies Division. I know that's probably a mouthful. And so I've been working with, AI technology for about, 4 years between building AI infrastructure and building AI applications, or what I'm referring to now as AI native applications moving forward, right? So there's this revolution of how to incorporate generative AI models into applications, right? So today we have a lot of legacy applications, and a lot of developers have taken the large language models and kind of bolted it onto the existing applications, right? So while that's a good experience, it doesn't bring this whole idea of what I call AI native experience into applications, where AI and large language models are just a part of the application and not bolted on as another kind of input-output mechanism. So we're going through in the development community, we're going through that that paradigm shift. How to build AI native applications and experiences, and really how to use large language models in the context of applications. So Microsoft made a big announcement of Copilot. So we look at large generative models like a Copilot, like having a smart agent next to you, helping you do your work by putting it, a large language model, into a context, and then asking it questions and helping it prompt, getting the kind of responses you need to help you do your job. So I'll start there, and thanks.
All right, thank you, Alan. And Dominic, you want to say a few?
Sure. So to start, can everyone hear me okay? All right, wonderful. I've never used a lapel mic before, so suffice it to say, like a lot of things about today are uncharted territory for me. So it would probably be underselling it to say that I'm really interested in all things artificial intelligence. Professor Straub here could probably tell you that. I've been working with him for over 2 years, particularly generative models like ChatGPT and Google Bard, right? Anyone who's actually played with these language models or seen them in literature, whatever, like have kind of seen how powerful they can be, as well as like some of the issues surrounding them. But the actual capabilities of these technologies are what I would like to focus on today specifically. And eventually I would like to kind of explore the intersection between how computers operate and how humans operate. A lot of computer-human interfacing. I think there are a lot of really interesting ways humans can use tools like ChatGPT to assist in their daily lives. Students, faculty, people, what have you. It's a really important tool. And I think we need to completely acknowledge its capabilities, limitations, and where to go from here. So.
All right, thank you. So again, I said I would start us off with a first question. Hopefully this is a good first question. And this is to both of you guys. One of the things, obviously, we're going to hear a lot about today is uses of this technology. And so, kind of from your respective perspectives, what do you see as the way you would interact with something like this the most, whether it's in the context of, what Alan, you just mentioned with some of the things Microsoft is developing, or Dominic, in the various roles you interact with it. So again, I guess, why don't we throw it back to you first, Alan? What would be the ways you would see yourself, Microsoft, and so forth, kind of interacting with this technology?
Well, looking at large language models as a platform, right? So a platform for building kind of next generation AI native experiences. So, we run the gamut of, participating from an AI infrastructure perspective, where there's, folks who are interested in AI infrastructure, building out next generation infrastructure for training large language models, which, I don't know how many people are aware, when you think about training something like an OpenAI model with 235,000 CPUs and 10,000 GPUs, right? So growing that training base, that platform for training large language models, and then building tools and experiences that allow developers to infuse large language models into their application, whether that be something like a cloud AI runtime that Microsoft recently released, something called Semantic Kernel, which is about giving developers sets of services that are important for them for infusing large language models in their application, like, specific multimodal prompting, vectoring, embedding, bringing a knowledge infused decoding, be able to bring knowledge into a prompt, submitting knowledge with the prompt, prompting the large language model to get the types of answers and information that you want. So, it runs the gamut between AI infrastructure and building applications and experiences and building toolkits and runtimes that allow developers to be able to build these things rapidly without having to delve deep into large language models or neural networks and some of the the deep machine learning topics, if you will.
All right, thank you.
Cool. And I suppose my experience with these technologies is drastically different because Mr. Stewart here is obviously in the industry. I myself am an undergraduate student. So I know some of the things that faculty specifically is worried about as far as these language models go is students using these to cheat on exams and assignments and stuff. I can promise you that I'm not doing that. If anything, like my most general use case of these language models is as like a supplementary learning tool, right? And that's where you get into the how these things are really good personalized assistants when it comes to educating for the most part, under the assumption the information they're giving you is accurate. Right. So like if I'm learning something really complex or whatever, like quantum superposition or something like that, these things are really good at spitting out outputs based off of the prompt. Hey, explain quantum superposition as if I'm a 5-year-old, and it can explain things in the context of analogies and like just ways that like people with little experience in specific domains can just wrap their heads around these things super easily. And I think to me personally, that's really helpful because I like to have a breadth first kind of understanding of different domains before I really get into the nitty gritty technical side of things. So like, for example, when I started learning C just very recently for one of my classes, I had the thing show me how to write hello world in C, like the most basic program that there is. And, that gave me some like fundamental understanding of the patterns involved with it, right? And then as time progresses, I can ask it to do more and more things and show me how to do these things. I think a really important thing to mention is that the thing is obviously really good at helping you get from point A to point B in terms of you give it an assignment question, it can give you an answer, right? I think one of the things people need to do is make sure that like they understand the process of getting from point A to point B, so to speak, understand like where it got its answer from. Because in the event that you need to go from like, say, point B to point C or something like that, and that doesn't exist in the language model, you need to know how to do it on your own. You know what I mean? So I would say my most general use case is as a supplementary learning tool, or sometimes I have it look over emails just to say, hey, is this respectful? Am I missing a comma or something? So those are my use cases as a student.
Great, thanks. Do we have any questions from the room? All right, well, I've got another one. Go ahead.
So I'm really curious. It's difficult to really, in my sense, to define AI because AI seems we're in North Dakota, the upper Midwest, where farming is key. Something as simple as evaluating soil conditions and then determining what to do to improve soil conditions to maximize farming output. That's AI. But what I hear a lot of discussion about is interaction with humans. And so is there like a dividing line there?
Well, let me start by repeating your question so the folks that are online know what we're answering. So for those online, the question was defining AI, and then you had a great example of an application having questions about soil conditions and how to actually improve soil conditions, not just answering the question, but actually, building on a knowledge base and how do we use that, and then trying to figure out what that translates to in terms of the human interaction aspect to it as well. Did I get all the parts to that?
Yeah, good enough.
Okay, so yeah, I guess Dominic, you want to take a shot at that first?
Sure. I mean, as far as defining AI goes, I would like to acknowledge Professor Jen Lee over at the Computer Science Department at NDSU for teaching me that there were 4 common definitions of artificial intelligence throughout the years. And they're making systems that can act like humans, think like humans, act rationally or think rationally, right? And what we care about now specifically is the act rationally bit, because we don't necessarily want machines that can think exactly like humans, because humans aren't always rational beings, right? And I'm sure a lot of you have seen stuff like that. So what we want is to create these systems that, you know, can think rationally, whether that means based off of like logic and reasoning and data that exists, you know, empirical trends that we've noticed over time, stuff like that.
Okay, excellent. Alan, do you have any thoughts on that too?
So yeah, I just want to comment on the actual scenario that the questioner mentioned. And it gets back to what something I've been talking about, how to infuse large language model into applications and take an application that wasn't necessarily an application infused or using artificial intelligence and infusing artificial intelligence into the application and increasing the experience you have from the application. So Microsoft actually has a system called Farm Beats. And it's about, you know, putting sensors in ground and predicting, you know, farm and soil conditions. So taking something like that and infusing a large language model into it, you know, I think the caller mentioned, like, you know, starting to predict, you know, soil conditions from past historic channels and data, and then using that, you know, for recommender systems and transformers that now start to predict and tell the farmer, you know, exactly when they should plant, et cetera. Infusing those into those types of applications and making it seamless, right? So it's not like today's experience. Like I like to say that, you know, the ChatGPT is the great worst UI I ever saw, right? So it's great because it's generative AI. It's not so great because it's just an input and output parameter. It's pretty simple UX, right? So now, you know, how do we take complex applications and infuse those AI experience into it via toolkits and runtimes, et cetera, and things that we're building. So I definitely, I spend a lot of my days thinking about incorporating, you know, how could we incorporate it for developers as a platform, the ability to use large language models. And so I completely agree with what the questioner was talking about, right? In that direction.
Great. Well, thank you, Alan. And I think, you know, there's another point in your question that we didn't respond to fully, which is maybe what the difference is between AI, this big concept, and then things like ChatGPT and Google Bard, which are language models. So I think that's something too we can take a second and talk about. And I think also too, Alan, I don't know how much you're familiar with Microsoft's involvement in the Grand Farm initiative. Microsoft is actually one of the original funders. It's something that's happening here kind of in the general Fargo region, but they're actually doing a certain amount with AI as well too. I don't know if they're doing anything or not with language models, but that's another kind of, I think, neat tie-in regionally to your great question. But I guess, Dominic, you want to talk a little bit about the difference between AI and language models?
Sure. So I suppose like there are two like very important distinctions when it comes to AI and language models, in that AI is an umbrella term, more or less, right? We're coming up with heuristics, models, and technologies that can think rationally and think, so to speak, right? Whereas language models are more or less a product of machine and deep learning, right? They are things that are able to look at like vast corpuses of text data, for example, and they can recognize patterns in human speech, you know, and that's really the key difference, is that large language models like ChatGPT and Google Bard, they aren't exactly hardwired to think a specific way. They are trained to identify patterns and, you know, act based off of those patterns. And that's where you get your output from when you put in an input into the ChatGPT, is that I don't know what exactly was used in the training data of these language models, but whatever it was really contributed to its output to an extent, right? Because it was able to identify patterns in its training data that were similar to what the person was asking in their question. So to summarize, artificial intelligence is very broad. It kind of encompasses machine and deep learning, right? Whereas machine and deep learning is placing emphasis on data. Deep learning specifically is about neural networks.
Yeah, I would definitely agree with that. We've spent a lot of time focused in on natural language for obvious reasons, right? ChatGPT, one of the quickly became one of the most used applications over a quick period. But there's vision, there's speech, there's all kinds of other modalities being researched around the generative term around artificial intelligence. You know, we're concerned a lot of information around natural language right now, but there's vision, there's speech, cognitive services, actually training and building machine learning models as well, right? And that's something that that I'd love for this community to kind of think about one thing is like training engineers moving forward, right? So even on my own team where I do, AI every day, we have a mix of data scientists, software engineers, and prompt engineering folks. I think even the skills now are changing rapidly around the space as well. So.
Great. Well, thank you, Alan. Thank you, Dominic. What I'd like to do, we have three from the web. So Tate, would you mind calling us out one of those, one of the questions from online? There we go. Or Daniel. Yeah, it looks like somebody's coming. All right. So can we just make sure we're going in order? Was that the first one on the very top there? So it looks like and I believe only we can see this in the room. So I will read this out for those that are connected online. It says, I have a technology question. My understanding is that ChatGPT, for example, does not have its own database. The internet is its database, or whatever you pointed at is the database. How does ChatGPT learn? Does it write its own code to expand how it thinks? So Alan, do you want to start with that one?
Yeah, so there's a few ways that models learn, right? Retraining the model, which is unfreezing the model and adding additional data to the model, which requires training, right? So that large training activity that we talked about in training large language models. And then we have what is called fine tuning, right? The fine tuning is the ability for you to teach a large language model a new task. For instance, like, if the large language model wasn't aware of the Go programming language, you can feed it the entire book of the Go programming language, and from that it starts to make connections from its actual data in the large language model. And then it learns how to do Go code from that fine tuning activity. So fine tuning is really teaching the large language model a new task to perform. And then we have this area that on the business side of things that a lot of people are interested in. Large language models are great. Large language models in conjunction with domain specific data becomes truly powerful, right? So if you're, the government, for instance, you train a large language model or task with your domain specific data, then you have a real powerhouse of capability that you can infuse into your applications, trained with your own data that knows how, a bunch of domain specific information moving forward. So.
Great, thank you. Dominic, anything to add?
Yeah, and Alan, I'm sure you probably know a lot more about the technical stuff. So if anything I'm about to say needs clarification or anything like that, by all means jump in. But the way that these language models learn is they contain billions or millions, I don't remember the order of magnitude, but it's millions, I want to say millions, of learnable parameters. Right. And what these are is they're basically just like tunable values that correspond to different outputs. Right. So think of it like from grade school, you learned y equals mx plus b. You remember that the point slope form, right, where the y corresponds to some dialogue output and the x corresponds to some text input. Right. And the trick is getting that m to a value such that the output it gives you is reasonable. I mean, realistically, it's way more complicated than that. The math is kind of insane and beautiful if you look at it. But like the actual learning behind it is really just updating different variables and those tunable parameters.
Great. Well, thanks, Dominic. Thanks, Alan. Do we have another question in the room? All right. Looks like the mic's coming over to you, Todd.
So I have a question on to our Microsoft guest on domain specificity and sort of how close we are. So an institution like NDSU is medium size as organizations go, but it's plenty big enough where the average staff or faculty or student might have challenges navigating circumstances, figuring out who to talk to, who knows what, and if you look at like a large enterprise, the question is aimed sort of from a enterprise focused product development future for Microsoft. A large enterprise, it can be extraordinarily difficult to navigate and networks themselves. How good your network within your organization you work for becomes a really potent thing. how far are we away from a big enterprise having the option to get a model trained on itself, all of its ongoing projects, who's working on them, the past history of those projects, to some extent, financial information, a firewalled trained model on basically all the communication and all the available OneNotes in their clouds, and then figuring out a tiered way in which people in different levels of the organization can access that information. So that because sometimes it'd be, well, we're not going to share those details with you, but at a certain level you could. So you'd always have like an aggregate entity of all the people that know something about different parts of the organization that previously you'd reach out to that person. Hey, who was in charge of this and who's running that now? And what's the budget for this? How far are we away from something viable like that?
That is a big question with a lot of different caveats, but I'll break it down into smaller components. So how far are we away from an enterprise being able to train and build models with their own domain specific data? From a technology perspective, I'd say that is applicable today. You can build that today with several machine learning platforms that help you take your unstructured data and build models out of it, right? So whether that's Azure ML, TensorFlow, PyTorch, Scale AI, there's so many different tools that help you take your data and build models out of the data, right? So that's the first aspect of it. There's tooling. Politically in large enterprises today, there's been, over the last 5 years, there's been a bunch of, hey, let's centralize and control our data. Let's look at, where our data is, where our mission critical data, and centralize that. So a lot of enterprises have been going through that, and that activity helps when they want to take and create, models out of their data. Now they at least have a centralized place or some understanding of where their mission critical estate data kind of lives. But there's still a political aspect of it that needs to happen, pulling data from business units, et cetera. Now, and then there is, how do we use that, right? So the fact that you have a model, doesn't automatically make a ChatGPT interface or anything, associated with that data. You have to build an experience from that data, whether it be a chatbot experience or infusing that model into an enterprise application, via runtimes and cloud native capabilities, right? So I say technically we're there from platforms, machine learning and data scientists being able to build models. From a tooling perspective, politically, something has to go on to enterprises where they centralize their data and they make a move towards making data knowledge via building machine learning models out of it. But that's a great question. It's something that, I spend a ton of time working with enterprises around their thinking and their future directions around this capability. So.
Great. Well, thanks, Alan. I love that phrase too, making data knowledge, right? That's powerful and a very important distinction, I think. So thanks for that question. Dominic, did you have anything to add to that, or should we?
No.
Okay, excellent. Well, let's go ahead. This question's been up on the screen here for a few minutes. I like this. I think this is a good next question. We've seen technology get rushed in the past with security not necessarily a priority over getting the latest and greatest out in time. With all of these companies pushing to get their product out faster at the front line of AI, do you see security being looked at enough when it comes to data loss prevention, especially with more and more companies integrating with AI within their own data set? So I think, Alan, maybe we'll throw that one to you first as well.
Yeah, this is something that I'm very intimate with, right? So, my team and myself, we're looking at how to infuse a new area of privacy enhancing technologies and capabilities into large language models, whether that be things like homomorphic encryption or confidential compute, where Intel or AMD enclaves and trusted execution environments, and whether that means encrypting the entire language model, right? So when you think about encrypting large language models, there has to be a bunch of additional research that needs to go on, right? So a model is made up of several layers, and running through general encryption practices, the timing around that, keeping it encrypted, is probably pretty challenging right now. But there is a bunch of work going on in the open source world, Concrete ML, and a bunch of even the Onyx framework is something that Microsoft participates in from a model perspective on how can you infuse, encryption and different capabilities, or encrypted endpoints into the models. So there's two sides: encrypting the model and protecting the model. And the other side of it is encrypting and protecting the input and output from the model. So the prompts themselves, because if I'm able to get the prompt, I'm able to reverse engineer the user's intent. So if the user's intent for what they're searching for is classified or sensitive, having that information allows somebody to reverse engineer what the user is actually asking the model for. So I think in the last question also mentioned too, levels of access to data. And that's something that, some of the machine learning platforms, their building models provide you, but there's a bunch of additional work that has to go on around encrypting models, providing access to models, and then protecting models and protecting the prompt input output from the models as well. So a lot of work going on in the security side of it. It's not lost on, Microsoft, my team. I spend a lot of time in thinking about, enhancing the privacy of AI via some of the privacy enhancing technologies. And the last thing is we have to mention responsible AI practices too, right? Transformers and the ability for you to be able to filter certain information and content from some of the models as well, all part of security as well. So big area, great question actually. So.
All right. Well, thank you, Alan. Dominic, anything you want to add to it?
No, that's his domain.
Okay. Excellent. Any more questions from in the room?
Thank you, Mr. Stewart, for being here. Thank you, Jeremy and Dom. I'm a journalist, and I have a question about when I think of how I would use GTP and all these large language models. If I were doing research, you're going to write about a contentious issue like climate change, for example, would these programs be able to there's really no such thing as objectivity in the sense that you can do your best at getting the facts straight, but you're always operating from a point of view, and these machines operate with algorithms. Will the machine or can the values or whatever be altered such that I could ask and get a fair representation? This is the mainstream academic and media point of view on climate change. Could you please give me the points of view on various parts of climate change from the viewpoint of the Heartland Institute or Professor Happer or whatever, so that you can get very, very good representations of very conflicting perspectives on things, rather than the algorithm giving you from a predetermined point of view?
Dominic, you want to start with it?
Yeah. So I suppose one thing worth mentioning is that language models like ChatGPT and Google Bard, at least right now, can only be as good as the data that was used to train them, right? The data is one of the biggest components that makes these things so very powerful. And objectivity is really difficult. I mean, one, because everyone has their own definition of what, how you would classify objectivity, right? And two, a lot of what they say in their output, these language models, is because of things that they have noticed in the literature that was used to train them, right? So these things are as accurate as the extent of how accurate the literature used to train them was. So say, for example, the team over at ChatGPT or OpenAI, they wanted to train this thing using online literature. They don't necessarily have it scrape the internet. That's my understanding. They basically handpick trustworthy sources. And that's where you get a lot of its answers from. It's also worth mentioning that the thing itself is not necessarily designed to be completely accurate. It's designed to sound human. And that's another trick right now, especially, is that in using it as a supplemental learning tool, I specify supplemental and not, as complete substitute, because there are cases where it's wrong. But there are cases where it's wrong and it sounds so right that you don't really look into how incorrect it is. It can say incorrect things with such confidence and quote unquote explainability that you'd almost believe it, right? And I suppose that's one of the big challenges is we really need to be careful about what data we use to train these things.
All right. Thanks, Tom.
Yeah, and that's also where learning how to interface with the model is important, right? So you mentioned something around environmental concerns, right? So when speaking to the language model, it's important to classify your persona of who you are. And I know a lot of people who haven't spent a ton of time with prompt engineering don't know this, but you can tell the language model, hey, I'm an environmentalist, right? So it puts the model in context, and it'll actually read back and say, oh, great, environmentalist is a great thing. So now you'll speak to me as if I'm an environmentalist and ask questions along that line, whether it be few shot learning or zero shot learning, and the questions that you're able to get back. And then it comes to a lot of the temperature and how you talk to the model and tell the model specifically how you want it to answer with, factual data, right? Because I think one of the things that surprised many people, they ask a question and they would get an answer back and they said, well, this is completely unfactual. And it was like, well, did you ask the model for truth or did you want it to fill in a story? Right? It's how you speak to these models is becoming pretty important. That's why, prompt engineering and understanding the API on how to speak to the model is important versus, becoming a deep machine learning practitioner and learning, every aspect of machine learning and the layers. Prompt engineering has become that abstraction over the model and allows you to really kind of have a pretty deep conversation with the model and get to the inner layers of the answers, closer to the answers that you want, and avoiding a lot of hallucinations that show up in models right today. So.
Right. And I think that's, again, this is a great question, Patrick. Thank you for asking it. One of the things that is different between ChatGPT and other older AI techniques is the ability to have that context, right? To do what Alan was just saying and say, think about this from the perspective of an environmentalist, from a student, from the perspective of somebody that holds a particular political belief. In the past, we could train a model, we could train a neural network, we could train whatever, and have it learn from only one thing. If everything that it was trained on was from a particular perspective, it would learn that perspective, but it wouldn't realize that it had that perspective. It would be kind of, in the perspective, but not realizing that it has, that context kind of built in. And so that's a really kind of neat advancement. If you think about how AI is moving forward in terms of what defines, evolution of AI, that ability to actually have the knowledge of your own perspective, that self-awareness aspect, even just the little nugget of it right there is really a cool thing. So again, thank you, Patrick, for that question.
So,
some great answers.
I suppose one of the easiest ways to conceptualize that whole issue too is like if the training data included a bunch of literature saying the sun was blue, this is just a quick comment, by the way. If the sun was blue, and you ask these language models what color the sun was, it would say blue, right? Like it has no methodology of determining whether the information that it's actually giving you is accurate unless it can actually look into its training data and can find patterns similar to what it's saying to you. And even if you ask it, if this is something that you can identify in the training data, it's not able to tell you. That goes back to a whole issue of explainability and stuff like that, which is another issue I would love to talk about if you gave me like 3 more hours, but.
Maybe next time. All right, so let's go with another online. The next question online is, can technologies based on a large language model predict something like the COVID-19 pandemic?
So I suppose that goes back to our whole notion of how good it is at pattern recognition, right? Like these things only know what it was trained on. So if people were talking about, hey, there is a pandemic imminent, then it might be able to tell you that, yeah, there's a pandemic imminent or stuff like that. But like, there's a whole lot of literature that was used to train it that was talking about how global warming is almost to a point where it's irreversible, right? And to that end, it can predict that global warming is going to be at a point where it's irreversible. And that's solely based off of the data that was used to train it. So hypothetically, it could predict something like the COVID-19 pandemic, but only if people did it first and only if that literature was used in its training data.
Okay, Alan? Go ahead.
Okay. And the way to make this more accurate is the large language model, fine-tune with biomedical data or airborne disease data from the CDC.
And I suppose that goes back to like an issue of data scarcity, where a lot of the data that we really need to do stuff like this just straight up doesn't exist. And I think one of the big challenges right now is getting people to understand that we use data. It's not just numbers on a spreadsheet. Like we use it for specifically machine learning and artificial intelligence. And for good reason too. It's to do exactly like what Mr. Stewart just said. Like hypothetically, if enough data on stuff like that existed, like all of the corresponding input variables to predict something like an epidemic like COVID-19, then yeah, it would be able to predict something like that. But again, it's just a question of whether the data exists.
I will say that something we're learning as computer scientists with these large language models is, we're still learning too. We're learning that the difference between, GPT-4 and GPT 3.5 is, GPT-4 is really great at math. And it's like, okay, why is it so good at math? You come to find out when we feed a large language model more language, the model gets better at math. So, it's kind of like, okay, then why, right? So we're still digging into a bunch of these topics as well, right? But it's just a really exciting time. So we're still learning stuff out of data, but to really get to that kind of, panacea of the future is that, look, there's going to be foundational models and then the domain specific models. And when you pull those together, then you're going to really have a super powerhouse of information that's able to predict things that just the individual language models wouldn't be able to do by themselves, because like I mentioned around the COVID, it may not have all the details of the CDC data, which fills in pieces of the large language model picture, if you will. So, yeah.
All right. Well, thanks, Alan. And, I think that, again, there's some really neat ideas here. One thing, Alan, you kind of started to touch upon that I want to call out was this idea of all the different places you can look for information, like the CDC information. There's been some discussion about whether we can even predict things just by seeing the symptoms of what people are talking about. Can you see a pandemic because people are buying something? Are they changing their their different purchasing patterns? Are they changing their activity patterns? And as people are putting stuff into chatbots, again, kind of coming back out to another one of your comments about how you might be able to learn about what people are interested in based upon what they're asking, you could actually use that input, the questions that it's being asked, as a form of input as well. So again, I think there's so many kind of levels that this can work on. And so I guess, again, another really great question. It looks like we have a question from Chancellor Hagrat who's got his hand up. So Chancellor, please go ahead.
Hey, can you hear me okay?
Yep.
Yes.
So I'm answering the question as a former nuclear engineer, cyber professor, and historian of technology, not as the chancellor. And I'm envious of people like Dr. Straub to be back in the classroom. But the question is novelty, paradigm shift, transform, given that the large language models are building massive existing knowledge, we have this issue of novelty. And I think of both the fact that the data is collected across already existing discussions and whatnot. And then also there is a dominance, which I saw this when I taught my cyber courses, of male-dominated profession. Not just male-dominated, but male-dominated, probably from good high schools and middle-class Americans. And so you get kind of a groupthink. And I think of the big breakthroughs in the history of science and technology. Einstein was a patent clerk. He was not in the mainline physics literature. He was an outsider who was able, with some help from a mathematician, to break in. I think of the man who invented television. He wasn't Harvard or MIT. He was Philo Farnsworth, a farm kid who barely got into Utah, and his inspiration was cutting a hayfield with a swather, and that gave the inspiration. Grace Hopper in the Navy, the only woman in the computation center, and she had the breakthrough, probably the first human machine language, and yet, computer science is dominated by such things and the language. So any thoughts? I throw it to Alan on this. How do we get to those paradigm shifts if we're getting such commonality? And then on the socioeconomic thing, I see that the ChatGPT 4, you're going to have to pay for that, right? So the Philo Farnsworth and a struggling patent clerk maybe couldn't afford, in their day, to be paying for this stuff. So any thoughts on that?
Yeah, there's a great thing on novelty detection, right? So, training is this idea of correctness in data, right? You train your model on correctness, and then you try to use novelty to detect outliers in your data, right? But that, that gets back to some of the responsible AI practices and bias in data, right? And how do we, seek to remove bias out of the data? Because just, data by itself, without any sort of novelty detection or human intervention or responsible AI practices and transformers that implement that, we can then find ourselves in a world of hurt moving forward. But yeah, so look, the process is, taking, what we consider correct data, infusing data scientists into it, infusing, bias detection at that time. So identifying outliers in conjunction with what we consider responsible AI, which is, you just can't detect just from general data, and then building from that correct data set, the transformers that detect anomaly, anomaly detection or, outliers in your data, and then transform from there. That's the way we've been doing it today. So with the economics of it, look, I tend to think that there's going to be a new front, right? There's the model wars, if I call them, right? So there's large language models, and then there's models, domain specific models that are already popping up across the spectrum of domain specificity and specific specializations. There's going to be a bunch of open source data sets, and the concept of a large language model is going to probably change from just OpenAI and Google and others to include other open source data sets that haven't even been made available today. I think the economic headwind against a bunch of open source large language models is, of course, the training that it takes to the training and the expense of training large language models that it currently exists. We're talking that, a significant headwind in that, right? So I think as new technologies, new hardware, come out of the data center and move into general purpose, then they'll become a lot more economical. Right now, if you're looking at the GPUs and the infrastructure to train these large language models, it's pretty extensive and in orders of magnitudes of millions of dollars, if not billions of dollars to use and leverage.
Well, thanks for the answer. And I would just say, Jeremy, I appreciate NDSU has done some breakthrough stuff on gender. Dr. Groneberg and you Code Girls got national recognition. So I know you're doing what you. And I'm not going to ask the question of how many women are on your team, Alan, and how many women are in the audience, Jeremy. But, I think we really got to be aware of the male bias that has been built in over decades. And I know the military is really struggling with it. But thanks.
I have a 12-person team, and 4 of them are women, and 1 of them is the engineering manager over the other developers.
Good. Well, that's good to hear. Thanks.
Great. Well, thanks, Alan. Thanks, Chancellor Hagrot. Dominic, you have anything you want to add?
I suppose another thing worth mentioning is cycling back to that, making sure underserved communities have ample resources when it comes to stuff like this. Because like you had mentioned, Albert Einstein, he was a patent clerk. For all we know that another person with the cognitive capacity of Einstein might be stuck in a lithium mine right now, just trying to scrape by, and for that reason alone, we have to make sure that specifically these underserved communities are given ample resources to understand these AI capabilities and how to actually assist in developing them and being part of the cutting edge.
I couldn't agree more with that. Absolutely.
Thanks.
So in my own career, I've built a great many mathematical models. For example, models of the operation of the electrical grid, or a model of the operation of a fleet of drones, or of a processing plant, things like that. And when we build these kinds of models, we always very seriously ask the validation question. Is the model that we've built valid? Is it useful? Is it an apt description of the system we're talking about? Is it trustworthy? Is it useful? All of those things. And so we have, lots of tools that we apply to try to answer that validation question. But then as we get into the domain of the language models and things like ChatGPT and GPT-4 and any of the generative AI models, we still have the validation question, I think. And I'm interested in any thoughts that you might have about this question of validation, or you might say the question of trustworthiness when we get into these kinds of language models.
All right, thanks, Ken. I guess, Dominic, you want to start with that one?
Yeah, I mean, I guess it's kind of cycling back to what I had mentioned earlier about how these things can be very confident in their answers, despite the fact that they're not always right. And, it's worth reiterating that these things are only as accurate as the data used to train them, right? Like its outputs are based off of patterns, and these patterns need to be accurate, right? People need to ensure that when we're including data involved in training these models, that the data used is accurate and representative of the real world. Mm-hmm. So to that end, validity, it's real tricky. That's one of those things where it's still a very open question, definitely something to consider. I feel like most of the problems in AI right now aren't necessarily technological, they're more like ethical and societal. So stuff like that is really interesting and valuable to think about.
Excellent. Alan? Anything you
Yeah.
want?
So you look at large language models, which, the idea behind it is how can I, pull all of natural language, 530 billion objects or 11 trillion objects into a large language model. And then from that perspective, now how do I, infuse other data? You mentioned you built a model. That gets back to that whole conversation around domain specific information and training, fine tuning a model with your information. I don't think many people understand that when you're asking a large language model questions, you can actually infuse data in the question and actually allow the large language model to learn more about the context of what you're doing, or you can feed it factual information as well. So in your prompt, if you wanted to feed it, data that is accurate or specific information is accurate, that helps the large language model, validate and then give you better experiences from answering your questions or data, if you will. So there's a whole concept of how to talk to the large language models to pull things out of them, because they're very big. They have a lot of context. And as I mentioned, it's only good as the data, but the data is very broad, lots of data. Now, how do you specifically speak to the context? And one thing is that a lot of the large language models all have sources. So the next time you ask a question of the model, ask the question of, what is the source of this data? And I think you will get, back, some wildly different answers, right? If you ask the model, what's the flight ceiling of a Black Hawk helicopter, it'll tell you the ceiling. And then you ask it the source, and it may say, hey, the Boeing flight manual or some other manual, or where it got its source information. So there's ways to kind of validate some of the information back out of them as well.
I suppose one of the challenges too is like if you ask it for an answer to some prompt, right? It will give you an answer. You will ask it to cite its sources. It will give you relevant sources, but not in all cases it doesn't cite the sources that actually contributed to its output, right? Like it can cite relevant sources, but that's not to say those sources that it actually gave you were used in actually dictating what it said there. And so I think that's another thing that's probably worth consideration for creating trustworthy language models, is that if they have a bold claim, they need to have bold evidence, they need to cite like things like direct dialogue in literature to understand how they came to certain conclusions. That's another thing worth discussing.
And I would also, moving forward, look, if the idea is today, you need to make, critical decisions from large language models, I'd say that's probably at this point in time, without extensive prompt engineering and understanding exactly what you're asking it for, and, very important skills around temperature, et cetera. It's probably going to be very difficult for anybody to take a dependency on making decisions, life and limb decisions on a large language model. But life and limb decisions on a large language model, which are domain specific data, is absolutely in context. And there's several enterprises and other ISVs that I'm working with that are doing exactly that. But it comes with their factual data sets in conjunction with large language models. Right?
Yeah. And Alan, going back to what you were discussing about the infusion of data in your input prompts, this is a panel on technology, so I'm going to get technical for a second, right? A lot of the learning involved with these language models is unsupervised and reinforcement learning, right? And reinforcement learning is, remember in elementary school when you play the hot or cold game? Like you have to find something in your classroom, your teacher will say hot or cold, like hotter or colder if you're getting closer, stuff like that. Like you can give it an input, it'll give you a corresponding output, and someone can gauge how accurate that output was, like how similar it sounds to like some sort of human somewhere, and that's one of like the underlying processes as far as actually training and, tuning these large language models.
Mm-hmm.
Excellent. Well, I think, coming back to what you said a second ago, you could get the answer, Alan, from the Boeing flight manual, or it could be, some comic strip somewhere that it read in, has a super duper Black Hawk helicopter that can go to the moon, and you might get that. And that actually ties really nicely into our next question, which is one from online. The Jim writes, one issue I've seen so far with ChatGPT is that it can be very wrong. He says, for example, I asked ChatGPT a question about a network attached storage drive that I have, and it mentioned something that I thought that it could not do. I asked it how to do that, and then it even then stated the answer was something like, it is pretty easy to do. However, again, he says the answer was completely wrong. Having AI assist with human learning is great, but when the output is wrong, it can be hard to detect. How do we mitigate this problem? So Alan, do you want to take first stab at that?
Yeah, hallucinations in the large language model is something that we're working through, right? So, there's a bunch of different settings that you can actually set: temperature, the fallacy settings, how much you want to get back. There's capability that's tuning the model for, getting to the right answer. There's also the context, putting the model into context to prevent hallucinations. The questions you ask today are really, really influence back what you get back from the model. If you just say, hey, just give me a summarization of something, it can come back and you'll look at it and say, wow, this is wildly inaccurate. And you could say, hey, well, summarize this book, this name, this title, this year, and you get back a different answer, right? So there's more experimentation going on, but one of the things that we're committed in is reducing the number of hallucinations from the models, but also infusing responsible AI into those hallucinations as well, creating things like transformers and filters on the data that get you closer to the answers that you want, but also remove a lot of the pontification from the model, if you will, right? You're asking it to think and, and pull from its sources information, and it will, right? Tuning that down, reducing the temperature settings in the models actually get you closer to some of the real answers that you want, and not a lot of the pontification from the model, but it's definitely a science in talking to the models and pulling information out of them. But there's something in how we actually train the models that reduces the number of hallucinations in the models as well. So yeah, this is an area that is going to be ongoing over the next few years in generative AI and large machine learning models moving forward. So something we're committed to doing. But yeah, you will see interesting answers from the models. I'll say interesting because wrong is sometimes wrong, because the way you're asking the model is you're asking it to think and reason from a bunch of data that it has that may be factual or not factual. So.
And I suppose another thing to keep in mind, I cannot stress this enough, is that it's language models like ChatGPT and Google Bard are not a complete substitute for, people with specific domain knowledge or other credible sources. At least they won't be for quite a while. That's my opinion, right? So it's important that if you're learning something, especially complex, to use ChatGPT and similar language models in parallel with other forms of learning, right? And that way you can kind of gauge its output, kind of get a sense of how accurate something is based off of like accredited literature that you've seen. But realistically, there's a finite amount of data used to train these things, and there's like a virtually infinite combination of different inputs that people can use when they're actually using one of these things, right? So it's like Alan had mentioned with the outliers and novelty. It's they do the best they can to generalize to new information. But that is always something that you can modify and improve.
Excellent. All right, can we go to President Cook and then back to Sean?
Right there in that answer, you mentioned not for quite a while. How long?
Oh, that's a wonderful question. You ask like Ray Kurzweil, like 2045. You ask me, I'd say we have like at least 10 years, like before I would trust it more than I would trust like a panel of professors, and that's probably being kind of like liberal too. I think it's going to take a while, right? Because especially right now, it's like obviously these things are only as good as the data used to train it. They're incapable of quote unquote thinking for themselves, kind of like a human can. Like humans are really good at synthesizing information in the world around them. These things are good at taking shards of human language and putting them together in a way that sounds reasonable, right? And Jan LeCun, he's one of the big dogs. I think it's at Facebook AI. If anyone knows, correct me if I'm wrong. But he mentioned that things like the transformer architecture. One of the things that make the ChatGPT and other language models so powerful are kind of like an offshoot from like the tendency towards artificial general intelligence. Like despite their complexity as natural language processing systems, they are not considered to be something, at least in the eyes of Jan LeCun, like something that brings us closer to machines that can think and act rationally and like humans.
Excellent. Alan, anything you want to add?
Yeah. I think if you're just thinking about the large language model perspective, I would probably agree with 5 to 10 years before they're accurate for making life and limb kind of decisions. But I'd be remiss in saying, if you're building machine learning models and creating chatbots over domain specific data where you have expertise and authority, you should be able to make decisions with those machine learning models today.
Right. And that goes back to, like, for example, I was working on a little personal project. I used the OpenAI API to actually get a pre-trained generative model like GPT-3. And you can do a thing called transfer learning. And in transfer learning, you can give it very domain specific knowledge, and it'll be really good at answering questions specific to that domain. But where it kind of falls flat from my experience is that when you start to ask questions about kind of like the intersection between that domain and other domains, that's when it kind of starts to become tricky, or things like forecasting over time. Professors can use their experience and their wisdom and know-how to predict where these language models will be or stuff like that in the years to come. These machines are basically, they're at a point where they can use data to do so, but they're unable to think or apply wisdom or, information from their environment to do so. Like they rely on things humans give them.
Mm-hmm.
Yeah, go ahead, John.
Good morning, Sean Riley, IT guy. President Cook, August the 24th, 2034. You're good right there.
Yeah, is there anything special about that date, Sean?
I'll share that later.
Okay.
So part of the conversation here is, as we listen to everybody talk about this, we're talking about absolute precision with AI. We're talking about absolute precision within these languages. We have created an expectation as a society already, even though none of this really existed years previously, but we've already created this expectation that it will be way, way, way smarter than us. And we are putting limits on AI that are expectations that are well beyond what we adhere to, right? We're talking about absolute correctness and absolute truth and absolute right, and et cetera, et cetera. So humans suck at that. And yet we fully expect it out of the tools that humans are creating. My question is, are we at a point where we need to we need to evolve the social communication to the world at large and say, this is a partner tool to you, right? It's a hammer. Not everything's a nail. It can be a shovel. It can be these other tools. But how do we need to evolve that language to help people realize that this is here to augment and help us, not to take over our universe and be perfect?
I'd say, I'll take that one, right? So it's even in the way we talk about the technology, right? So, the technology will help you, the technology will do, versus, the Microsoft message is the technology is a co-pilot, right? Look, you are the software developer. The technology is a co-pilot. You're developing something. If you haven't developed a function in Go for your particular area or problem you're working on, having a co-pilot that says, hey, do you know how to create this in Go? Have you send me a code sample of how this works in Go? Code sample, incorporation, learning. Now you're more productive as a developer, right? So it wasn't an authoritative answer. You asked it a question, it gave you some results, you're able to incorporate it, and you're able to continually move forward, right? So thinking about it as assistant as you do your work, whatever context you're in, you're an information worker. So now, if you're in the Teams UI, you're able to say, hey, give me a summary of the last meeting. And it says, from its transcripts, it summarizes, and it says, well, summarize the key issues from the meeting. And you get a report that summarizes the key issues. You would have had to write that report as an information worker. Now the AI or the co-pilot information is just helping you, assisting you along that direction from the additional data, right? So, yeah, thinking about it as a co-pilot versus thinking about it as it's going to do a task for you, it's assisting you along that effort is big in changing the mindset around how the technology will be used or should be used moving forward. So.
Thanks, Alan. Dominic, anything?
No, and I completely agree. I think ChatGPT and similar language models are one of those things where you should really don't consider them as a tool to supplant you, right? Like, don't have them replace everything you do. Use them as, like it's called the co-pilot, right? Use things to kind of use these things to guide you in the right direction or provide guidance and stuff like that. Because we're talking about this in greater detail in the education panel. But if we have to do less thinking, over time, we're going to get worse at it. And that's not something we want to do as a society, right? Especially when we're at such a vulnerable position in terms of our technology capabilities right now. These are technologies that we really don't want to completely supplant us, especially in the near future, because there's so much work that's still yet to be done.
Excellent. And so I want to jump really quickly. We actually have two related questions in the chat here. So I'm going to bring these together into one, and then hopefully we'll have time to take one more question in the room after that before we wrap up. So our two questions, first one is chatbots cannot produce, yeah, they actually just say cannot. Chatbots cannot produce responses based on information after their training. What solutions are underway to fix that? And the second kind of related question as it relates to kind of accuracy and quality, do you think that the producers of ChatGPT and Bard are doing a poor job of emphasizing their product's function to sound like a human, not to produce a correct answer? And if so, why would they do this? So again, some questions about quality. The first question was directed at Alan. So Alan, I'll let you take a first shot at both of them, if you wouldn't mind.
Yeah, I think one of the things that show up completely in that everyone that starts to use the ChatGPT interfaces. Hey, whoa, this only has data up to 2021. So how is this that useful, right? How do we get the latest data into it? And I think, those of us on the AI side of it, we kind of think hey, it's just not a button you click, right? This whole model has to be trained. This is a huge model, huge infrastructure that has to go down around infusing, unfreezing a model and infusing new data into it. But there are ways, are things going on, right? So there's a concept of federated learning that's happening. How do we keep machine learning models in sync? Because now when you think about it from an enterprise perspective, machine learning models, it's sitting in the data center are useful, but what about on the edge? Edge devices, right? So, there's military applications, there's all kinds of applications on having a model on the edge and being able to, do recommendations or infuse stuff from the model on the edge, right? Every iPhone eventually will probably have a machine learning model associated with it. So, how do we get those things on the edge? And how do we keep the edge federated with new data, right? So federated learning and machine learning is an aspect of research that's ongoing that will help us around this whole idea of continuously learning and continuously training models. The other side of it is fine tuning. We kind of overlook fine tuning. Fine tuning, the ability for you to teach a model about a task, a new task, or new information, right? So whether that be new data sets, new information from on a yearly perspective, or new information about a specific topic, is a way for you to teach the large language model about new areas and new data and new tasks. So the fine tuning works without having to unfreeze the model, if you will. So those are some capabilities that are ongoing right now to, how do we do this? And I want to, one thing it'd be remiss to bring up, this is a problem with large language models. You building your own model today, which you can from your own personal data or from enterprise data, that becomes, hey, a different exercise, because you don't have a dependency on somebody else for retraining this super huge large language model. Now you can retrain the model yourself, or come up with federated learning topics from keeping it updated all the time for the interval that you require. But that's actually a great question. So.
Very well, thank you, Alan. And Dominic, anything you want to add to that?
Kind of bouncing off what Alan said, we can go back to the discussion of transfer learning, right? Where we take these pre-trained models and how complex they already are and just kind of have them narrow down on specific information, right? There's ways to tie in recent news with these language models. It's just a question of, actually curating the data such that the language models can use them in a way that helps it to learn. And that's really one of the issues that they're trying to solve right now is that like basically these language models, they don't really see words the way you and I do. They see, they see numbers, they see embeddings, right? Every word that you give these things corresponds to some vector of numbers, right? And that's a challenge. We need ways to adequately convert human text into these numbers such that the language models can understand that. And that's particularly true for things like recent news, literature. So for these things to understand what's going on like right now, as far as current events go, we need to give it literature of, recent history, because I'm not sure if any of you guys have seen, but ChatGPT, I believe the knowledge cutoff date is something like 2021 of September 2021 specifically. But another thing that I noticed is you can ask it questions like, who's the CEO of Twitter? And it'll say Elon Musk, which is something that happened after September of 2021, which begs the question of how exactly did it learn stuff like, hey, Elon Musk is the CEO, especially if that is something that happened after its, supposed knowledge cutoff date. And my guess, my knowledge is limited, Alan might be able to shed some light on this, but is they used a similar transfer learning approach, right? Like they took literature from credible sources of recent history, fed them into these models that are already very, very complex, and basically just piled on some new knowledge onto what it already had.
All right, well, thanks, Dominic. And then Todd, I think we had a question up here. He's coming to you with the mic behind you.
So, hi, Alan. My name is Ashley, and I too work for Microsoft, but over here in Fargo. But I work in finance. Dominic also happens to be my son that's on the panel. So in a very small world. So I was just made familiar that my team is going to be taking on Copilot launching this week. What is it?
Okay. So which
a live product announcement here, Alan? Do we need to alert the media?
No, I think, yeah. So look, there's a lot of things that Microsoft are going to come under the Copilot umbrella, because we got back to that whole question around, look, how do we see these things? We see these things as a Copilot. So I believe what you're saying, you're taking on Copilot. So Copilot, the first product Copilot, was the extension that was integrated into the development IDEs, whether it be Visual Studio Code or Visual Studio. And what that was in partnership with OpenAI, we had GPT Codex model, which was trained on all the development languages, right? That's since being deprecated. Now GPT-4 could just actually code for you. But putting the extension in the IDE that allows you to have large language models, that large language model assistant trained on all the development languages next to you in the IDE. So when you're actually working through problems, when it sees a problem, it can actually recommend things, or you can talk to it and say, hey, take a look at this piece of code. How could I optimize it? Based on what everything about every single line of the Python language and how people have used it over, 100 million different repositories. Is this code proper, right? So Copilot is the development part of using the IDE to build applications. And the Copilot there is a development engineer that's been trained on all the different programming languages, some more complete than others. So that's what that kind of means. So now, internally at Microsoft, every developer has the option of using Copilot in the IDE for everyone to use. So.
All right. Well, thanks, Alan, and thanks for that question. And again, kind of interesting, embedding a little bit of a product launch, always cool. So that brings us to time for this first panel. Again, we're